panel datasets. First thing you need to check about panel datasets is that are there any stable long-term, I repeat, stable long-term relationship in your datasets for cross-section entities? Are there similar relationships? If I wanted to check about this scenario or assumptions, I need to use a test named co-integrations. Co-integration test. In Stata, we can use some exams for to check about a co-integration test. For example, KO, Pedroni, and Westerland. It's simple to copy these codes and go here and paste. Click enters. Okay, difference. Zero or null hypothesis in co-integration test is that there isn't co-integration in your datasets. Then we need to reject the null hypothesis. And in my datasets, we see that, for example, with Pedroni, we see that null hypothesis are rejected. And for KO, it's similar or modified Dickey-Fuller test, and for Westerland is similar. And now we can conclude that in my datasets there is a stable long-term relationships. Another step is to check about stationary difference. When we have time series or panel datasets, we need a datasets that are stationary in mean and especially in mean and in variance. Then how to check about stationary in mean? In Stata, there is some tests to do this. For example, the Levin-Lin-Chu is usual type of exams to check about stationary in mean. It's simple to use the Levin-Lin-Chu test. You need to write xt uniroot and Levin-Lin-Chu in abbreviations LLC. Then name of your variables, then write trends. Copy these codes and go here, paste, and click on enters. Now, Levin-Lin-Chu null hypothesis is that panels contain uniroot tests, means non-stationary relationships, and we need to reject null hypothesis to conclude that panels are stationary, and for pcap variables it's assumed. But for another variables, if I want to check, so I need to copy these codes and paste here and click on enters. In other words, I want to show one violation of stationary in mean and how to correct for stationary. How to do this? Here we see that for GSP variables adjusted to p-values is more than 5%, and now for this test we conclude that we accept null hypothesis, means non-stationary in mean for this GSP. If I want to show geometrically this, it's simple to use these codes. Now we say that we need to show a two-way plots and line plots for GSP and year. Now we see that we have for some state of USA GSP have trends. For example, so for these states we have increasing, for these states we have decreasing, and for some of the states we have stationary in variations. But now we want to have stationary in mean for all of states. Then we need to use differentiations. In other words, the correction for non-stationary in mean in a panel dataset is differentiating. Then I write here gen GSPD1 means the first differentiating equal d capital dot GSP. Now Stata create a new variable named GSPD1. It's added here. Then we need to repeat x the unit root test, but this times for GSPD1. Click enter. And now we see that null hypothesis rejected with first differentiating. If I wanted to show this correction schematically, I can copy and paste here, click on enter. Now we see that around 0 we have a variations around 0, not far from 0. And if I wanted to show GSPD1 with GSP in a unit plot, excuse me, a unit plot. Now it's this plot. Now below line is for GSPD1 and it's similar to a straight line, and GSP is for GSP variables and have variations increasing, decreasing, and but for GSPD1 we have a stationary in mean. After stationary in mean, we need to check about stationary in variance. To check about stationary in variance, there is different methods. For example, Leven test is a usual and common test to check about homoscedasticity in or homogeneity of variance, for example in ANOVA. And now we can check about homogeneity of variance in panel datasets by states, by panel ID. But how to do this? To do this, you need to install a package that I write the codes here. You need to write net install and the name of this package. Then you need to have regressions in Stata. Then write regress your dependent variables and your independent variables, and you need to save and predict your residuals. Then we need to write predict residuals and save as residuals. Now we see that a variable named residual added to my datasets. And finally, you need to use these codes. Rob there. Then write your variables means residuals. In other words, I want to check about stationary invariance for residuals, not for any dependent or independent variables. We need to check about stationary invariance for residuals. Then write rob there residuals, and I want to check about homogeneity invariance by state. And I click enters, and we see that for different type of comparisons, we have reject null hypothesis. And now we see that my assumptions homogeneity and variance rejected. When you have these positions, you need to use robust regressions. For example, if I want to analyze panel datasets, now I need to write regress, dependent variables, independent variables, and finally VCE in parentheses robust, means robust to homogeneity of variance assumptions. And then if you click enters, you see results or reports of Stata for these regressions. But if you can accept null hypothesis and homogeneity invariance, you can analyze your datasets with the usual regressions, and you don't need to use VCE robust regressions.